Okay, again, we're at Holmes Trucking. This is our little gasoline engine, but we're talking about diesel engine oil lubrication. As you can see, when this crankshaft throw gets all the way to the top, that's top dead center of the piston. The piston's at the top of the head, in line with the connecting rod, and the crankshaft throw is at its highest point. That's TDC, top dead center of this. Now, I'm going to talk about reciprocating piston engines a little bit. They're a little bit inefficient. I'm going to talk about that just a little bit. And here's where they're inefficient. When everything's lined up just like this, top dead center, piston rod, and the crankshaft throws at the very highest point, you really have nothing turning, applying power to make this shaft turn in a rotary fashion. Now, once the diesel fuel's fired, it's going to push the connecting rod and the crankshaft to create from reciprocating motion to rotary motion, just like this. See if I can get on it good enough to turn it. See if I can turn it from behind so you can see it. I'm not strong enough. But so right here, as the diesel fuel is burning inside the combustion area, this reciprocating engine becomes more efficient. Peak efficiency is right here, and the crankshaft throw is at a perpendicular, or it's offset. It develops a maximum amount of power right here because of the crankshaft throw. From here to right there is its most efficient point. That's when the power is created from reciprocating motion to rotary motion at its most efficient in this engine. And when it comes up here, it's extremely inefficient because the flywheel has to carry this crankshaft through back to its power stroke again right here. Now, this is a 4-cylinder engine. It has to make 2 full revolutions to get through all strokes. Now, let's talk about lubrication for a minute. The lubricant in this engine will be about at this level. The connecting rod will actually hit the lubricant and sling the lubricant up in here to lubricate the piston. And that's how we get lubrication. As the piston comes down, the scraper ring scrapes some of the oil off, leaving enough oil on the cylinder walls for lubrication. The engine oil also lubricates these gears, lubricates this connecting rod right here, and lubricates all the internal parts of this engine. John and I were able to take the camshaft out of this. Here's our cam. It goes in here like this. You can see the lobes on the cam. Here's our cam followers. This cam, as it rotates, these followers go up here, and these lobes push these valves open and close on a timing basis, to close all the valves, to open the exhaust valve, to open the intake valve. And that's how these work. Now, diesel engines are exactly like this, an internal combustion 4-stroke engine, but hopefully seeing this will help you understand a little bit more about how lubrication takes place. Now, I also talked at the end of the last video about oxidation. Anytime you whip air, and that's all you're doing, or whip oil with air, you're oxidizing the product. You're mixing oxygen with the lubricant. That degrades the lubricant. And then when you add metal to the whipped lubricant with oxygen in it, you further degrade that lubricant. And that's how heat degradation happens. So this engine oil has to not only fight against degradation through heat, absorb the byproducts of combustion, keep this engine clean, which this engine's extremely clean. I mean, there's no sludge in this engine. It's an old engine, it's old and wore out. But the lubricant that was in this engine, and I don't know what it was, has done a great job because we don't have any sludge buildup anywhere. Everything's nice and shiny, and the engine's actually wore out. That's about it for this time. Next time we'll talk about how this engine is being cooled, and we'll talk about hydraulics and some other things. Hopefully this will give you a fundamental understanding of what's going on here, and it'll help you to sell lubricants in the field.